and we'll give it just a second. Usually takes about 20 seconds to get to YouTube. Okay, I see it on YouTube. So yeah, whenever you're ready, you can switch to the introduction. I'll mute myself.
Hello. Today we're going to be continuing our study for the ISC Squared CISSP exam. Today we're going to cover Domain 4, communication security. It's a lot of networking, a lot of other pieces. If you haven't been following along on the streams, we've gone through the first 3 domains of the CISSP. My name is Michael Buckby. I used to have a CISSP certification, but due to an oversight on my part and not getting any continuing education credits, I let it lapse. And so now this is my quest to regain my CISSP credential so I can put it into the little signature line on my email. I don't know if it'll make people take me more seriously, but couldn't hurt. And today we're going to go ahead and get started. As always, I encourage people to play along as we work through the questions. And whoever does the best job answering questions gets a lovely Yeti mug. So we've sent out a couple of these already. They're very nice. Mine has water in it. Still works. And let's go ahead and get started. I'm going to share my screen here. All right. So we're going to work through these questions, encourage people to try to answer for themselves. Whoever answers the best across the day, we are going to then give out the mug. So I guess, yeah, stick around to 12:45. Yeah, we'll give it out sometime around then. Okay. Okay, so this is used at the media access control layer to provide for direct communication between 2 devices within the same LAN segment. Is it a rule, perhaps? Let's see. Address Resolution Protocol, ARP. Okay. See what kind of day this is going to be already. All right. The media access control layer to provide for direct communication between 2 devices within the same LAN segment. Address resolution. Okay. All right. The most essential representation of data 0 to 1 at layer 1 of the open SI. You know, let's just do this. Like, I have not reviewed the OSI model for a long time. So, as this is going to be that, I'm just going to run through this to refamiliarize myself before I then go back into the questions. This is one of those things I feel like is really important for understanding. Oh, and I forgot, we're going to play some music today. The music's supposed to help you better have the knowledge seep into your head. If you don't like it, I can change it, but we'll see how it goes. All right. So, 7 layers of the OSI model. Physical, data link, network, transport, session, presentation, and application. I saw a guy with OSI level 4 license plate before, which was great for the transport layer. Okay, conceptual model. Yeah, so we want to understand all the layers here, but I find a lot of times it doesn't translate that well into the practical of this, but it's still very important to understand, I think, more from almost like a security architecture standpoint, or that there's a certain attack and you understand like how it intersects, or like, you know, if people can physically unplug the cables going into your switch and flip that around, you're doomed in any case. All right. So, okay, contents, let's just skip down. So we're going to go up from layer 1. Okay, physical layer responsible, very good. Data link, node to node transfer. MAC layer, logical link control. All right, link between 2 directly connected nodes, corrects errors at the physical layer. Network, turn that from one to another, connecting different networks. So different LAN segments potentially, if the message is too large. Okay, transport from source to a host. Flow control, segmentation. transmission session. Oh, geez. Even today, I feel like full duplex and half duplex, all that stuff should be auto negotiating, and it so rarely is. Gracefully closing a session at TCP versus UDP, which doesn't have that. Okay, a presentation layer. Context between application layer. See, this is the stuff where it starts, to my mind, to get like out of networking and into applications, which I guess is true, but at the same time, like, All right, one for the application layer. Now this is interesting. Like, I think it helps with the practical examples. This is saying that there's two application entities, HTTP and then the database would have different. Yeah. I mean, in my mind, this is really ports on top of, TCP, or I guess your IP, your host. And then you have the different ports open, like HTTP would be 80 and 224 or 446 for SSL, whatever it is. One of those is probably SSH. All right. Has anything to do with reservations, the logics in the application. Okay, so now we're going to skip back to our questions and hopefully do better here. Can I mention the certifications I currently have? I do not have any other certifications. Mostly what I have is practical experience. I worked for a really long time as a Linux system admin for a bunch of startups. And then I've also done a huge amount of just like technical web, firewall, application, security stuff. And I was a working web application developer for a long time. So that's where most of my experience is. At Varonis, there's a lot less in terms of web application. So it's a lot more like Windows system, cloud kind of stuff that we're working on now, where I have a lot of, again, just practical experience and less on the certification side. So part of the whole process of this is trying to get back in and get those certifications, at least for the CISSP. My ultimate goal is maybe this year to get the OSCP as well, more of the offensive pieces, where again, with my background as a developer, I've just done less. Okay. Most essential representation of data at layer 1 of the open. So layer 1 is physical. This is binary that they're just asking for. Bit. So they're saying a bit. Oh, it's the representation of data at layer 1 of the OSI model, which is weird too, because I would think layer 1 is just physical. Transmission and reception of raw data, digital bits. The layout of pins, voltages, components of physical layer. Okay. All right. Essential representation of data. All right. Bluetooth wireless technology is an open standard for short-range radio frequency communication used primarily to establish wireless personal area networks. It's been integrated. I think we're switched here. All right. This is describing what Bluetooth is. But it's interesting, like here it's saying like part of the physical specification is actually for the wireless as well, which does make sense that you would have like the negotiation for the different like Wi-Fi protocols as part of this. And if you want to follow along at home or do this yourself, Quizlet, this is information put out by ISC². As part of their study guide materials. It's free. You can just go to it right now. You don't even have to sign up for it. Layer 2 devices that filter traffic between segments based on MAC are bridges. Filter between segments based on media access controls. So MAC addresses. So bridges. Okay. So bridges as opposed to segments. All right. Radio network distributed over land areas called cells, each served by one fixed location transceiver known as a cell site or base station. A cellular network. But isn't it, because you'd think of this as like we all have mobile phones when we call it like the cell network, but it is a generic term for that. Okay. All right, every call's data is encoded with a unique key, and the calls are all transmitted at once. So it's asking, what is this scenario? Encoded with a unique key, then calls are all transmitted at once. TCP, code division multiple access. So CDMA, call data is encoded with a unique key, and the calls are all transmitted. Code division multiple access. Okay. Multiplex connected devices into one signal to be transmitted to a network. To one signal. Concentrators? Wow. So this is where the practical and the theoretical just like split. Like, I don't think you can go to Cisco and say like, hey, you know what I really need is a concentrator. Multiplex device to one signal to be transmitted on a network. Okay. Is a large distributed system of servers deployed in multiple data centers across the internet. It's a cloud, or I guess like mesh, content distribution network. A large distributed system of servers deployed in. This definition is kind of crazy to me, in that a CDN is a lot of things, and this is like one particular one. But if you had, say, a AWS app that was in 2 availability zones, or 10, that would certainly be this. Or if you had like an edge network app like Cloudflare Workers or something from Fly, it would also meet this. It's a little weird that it's down to just this. Usually I think of CDNs as only working with like static data. Okay. Not a lot of suggestions today, so whoever answers is going to win this mug on mouse. Let's see. Okay, ports 49.152 to 65535. Whenever a service is requested that is associated with well-known or registered ports, these services will respond with a dynamic port. Is this dynamic port allocation? I'm not quite sure what it's asking here. Whenever a service is requested that is associated with well-known or these services, dynamic or private ports. Requested that is associated. I'm just skipping to the next track. Okay. A lightweight encapsulation protocol and lacks the reliable data transport of the TCP layer. It's probably UDP. Not what I was thinking of. Fiber channel over Ethernet. Lightweight encapsulation protocol and lacks the reliable data transport. Let's look up TCP versus UDP. Connection rate is connectionless. Speed of TCP is slower while the speed of error check. Fiber channel. Storage area networks. It's encapsulation. Ethernet switch. Okay, so here we go. Fiber channel is lossless. Fiber channel switch is lossless. Well, Ethernet at the risk of dropping a frame. Yes, absolutely. Let me turn on the music. I don't know. I figured everyone would rather listen to music, even if it's royalty-free chill hop, than my own voice. Because the fiber channel switches will stop sending frames. They're dropped when congesting. This is interesting. A lightweight encapsulation protocol and lacks the reliable data transport. That's just familiar. Okay. So originally fiber channel was like tied to a physical medium, like you'd actually have fiber connecting your servers to storage area network. But this then puts it over Ethernet because it's way easier to deal with Ethernet than running fiber. And Ethernet has gotten so fast. Then it runs the protocol for this encapsulated. I'm just trying to figure out which encapsulates what. A lightweight encapsulation protocol and lacks reliable data transport. Okay, so it's not happening at TCP, and instead it's running on the network over Ethernet and taking Ethernet frames, but as fiber channel. Lacks the... Okay, so I think I was misunderstanding this. This isn't saying that it's encapsulated by TCP or the other way, just that it's different, which makes more sense. Okay. Devices that enforce administrative security policies by filtering incoming traffic based on a set of rules. Oh, yes, man. Anyone have a guess on this? I'm going to give it like 10 seconds. And we'll listen to whatever this music is in the meantime. Devices that enforce administrative security policies by filtering incoming traffic based on a set of rules. My guess is Firewall? Enforce administrative security policies. This gets tough because, typically the term firewall now really represents inter-network communications, and that's where they're placed. That you have a firewall that keeps traffic from, the internet from getting into your internal applications or something like that. You don't normally think of like enforced administrative security policies internally as a firewall, like VLANs or something. Okay. All right. Pranay, I hope I'm pronouncing your name correctly. Got firewall right. Okay. Here we go. Data represented at layer 2 of the OSI model. Okay, so let's cheat and go look at our OSI model. The data link layer provides node-to-node transfer. The MAC layer logical link detects and corrects errors. So what is this asking? Data represented at layer 2 of the OSI model. Anyone else have a guess? Layer 2. Doesn't really have a description of what the actual data would be. Unencrypted data? Well, let's see. Frame. Data represented at layer 2. Okay. I wouldn't consider that the actual data. That is literally like the frame around the data. You talk about like Ethernet frames or something. So let's look that up. Like Ethernet frame. Okay. Data link layer protocol data. Start SFT. Ethernet packet at the physical layer. Ethernet frame starts. Okay, and this somewhat makes sense in terms of like the fiber channel question too, which would instead... Hi, Zam. All right, Ethernet frame. Okay, and so then the fiber channel over Ethernet would be inside of these Ethernet frames, is my understanding. We'll keep working on this. Okay. So data represented at layer 2, I guess maybe it's thinking data is inside of Ethernet frames at layer 2 of the OSI model. Okay. Each call is transformed into digital data that is given a channel and a time slot. Global system for mobiles. Call is transformed. I guess in this sense they actually mean like call as in...
Each call is transformed into digital data that is given a channel and a time slot.
That was terrifying. Okay, each call is transformed into digital data that's given a channel. I guess if we were looking at a list of like CDMA versus GSM or whatever else for this, it'd make more sense. So these are different cellular data transmission systems. So, all right, Sam's causing trouble. Sam, if you answer questions correctly, we'll send you a Yeti mug. Okay, provides a means to send error messages and a way to probe the network to determine network availability. Open to ideas here. If you click on Quizlet, like on the actual words, it'll start reading them. I don't know if that's better or worse than me reading them. But as this is also me kind of cheating and trying to study this myself, I think it's better if I read them, like it goes in my head better. Okay, a means to send error messages and a way to probe the network to determine network availability. ICMP? No, it's not an ICMP. Which would be, that's a way to probe the network. You could send, ICMP packets, pings, to look at it. Means to send error messages in a way. Oh, that was ICMP. I don't really know this means to send error messages. Now I'm curious. ICMP. Thank you everyone for turning into Mike digs through Wikipedia entries stream. Let's see. Okay, ICMP error messages. A data section includes a copy of the entire place. Oh, okay. The ping of death. Largely used for denial of service attacks. Oh, this is interesting. I hadn't realized this. I have heard of these, but I hadn't really thought about the implications for like it as a protocol. But so what this is saying is you could set up a denial of service by making a bad ICMP packet that you know is going to error and cause like a really big error message to be returned. And so then you can asymmetrically take down a service by sending it a very small ICMP packet, a ping, that's malformed that then sends back something like 10 or 100 times larger because it has like all this error information in it. Okay, cool. All right. SNMP provides a method for managing ICMP. Yeah, I think it's entirely a different protocol. Is SNMP over ICMP? SNMP versus ICMP. These are almost all other statistics. Yeah, I mean, you could block ICMP at your routers or whatever, but okay. Performance management is used for availability calculations. SNMP is used for also. This is networkmanagementsoftware.com. WMI. All other statistics. I feel like SNMP is different. SNMP. I just want to know if this is actually based on ICMP. It's widely used in networks. Overview and basic concepts. Trap receiver. Tool use and manage. I'll just look for ICMP here. ICMP. No. Okay. Well, good enough to start. Thanks for chiming in with that. So, okay. Used to manage multicasting groups that are a set of hosts anywhere on a network that are listening for a transmission. I think this is just multicast. Yeah. SNMP is very different. Yeah. I just wanted to make sure SNMP wasn't a set of services based on ICMP, if that makes sense. Okay. Used to manage multicasting groups that are a set of hosts. Anyone have an idea here? I think it's just multicast. IGMP. Oh gosh. I honestly had not even heard of IGMP. Interesting. Well, I certainly won't confuse that with ICMP. There's not enough acronyms here. IGMP. Okay. All right. Is a wide area networking protocol that operates at both layer 2 and 3 and does label switching. So it's maybe BGP, Border Gateway Protocol? No. Multi-protocol label switching. Oh my gosh. All right, well, let's look up BGP versus multi-protocol. All right. BGP. It's a functional routine. All right, for doing provider network. This is like too much for this. Okay, I'm just going to go back and go to the next one. Yeah, IGMP. Okay. Physical layer. What is the physical layer? Physical layer is layer 1 of the OSI model. Sure, that will be on the CISSP test. And that includes both the physical setup. It's like literally the configuration of the cables in your Ethernet cable, as well as the how information is represented at an electronic level, whether it's like an analog signal or it's bits on a wire. OSI layer 1. Hey, I got one right. That's nice. Yeah, so many four-letter acronyms. All right, data link layer. Okay, so let's cheat and look at our OSI model. So we got network layer. All right, 7 layers. Data link is level 2. Oh, this is nice. This protocol data unit. Okay, so this is helpful here. So we got data link, and we have the frames, network packets, transport segments, datagrams, session. And this is all just data. Because at this point, I really feel like the OSI model breaks down as this is all just a giant bit of mush. Okay, but this is helpful, these 4. So data link layer has frames. All right, studying for Security Plus and 501. 501? Not sure what that is. Studying for an HTTP status code. So, all right, data link layer, OSI layer 2. So this is just asking what layer these are. Okay, network layer is, I just forgot. Is that 3? It's just going in order. There's probably some fun mnemonic. I found a list of like CISSP mnemonics. Maybe we'll go over that. All right, transport layer is 4. So these are just going in order. 5. Session presentation is 6. Application is 7. I'm just going to go back through these real quick because they seem so important. All right, physical is 1. And at that level, it is bits and symbols. I got 2 click happy. So, all right. Tech people, academics love acronyms. Most people think my name is one. It's not. It could be. Okay. Zero trust is a big thing. It could be like zero access middleware. Okay. Data link layer is 2. Data link layer works with frames. Okay. Network layer is layer 3 and works with segments. Transport layer works with datagrams. Is that right? Or else, packets. Network works with packets. And transport works with segments and datagrams. Okay. Session layer works with data. Presentation layer works with data. And application layer works with data. Okay. The objective of NFV is to decouple functions such as firewall management, intrusion detection, network address, or name service version away from specific hardware into software. NFV, I do not know. At least it's not a 4-letter acronym. So we're already improving here. Does anyone have any idea what NFV is? There's no points deducted if you Google it really quickly and then just tell me. Objective. It's probably network. Network firewall verification, network defined. No one has a guess. I'm going to go network function virtualization. Decouple functions. This is where like me being a developer holds me back. Like I think of function so much as like, oh, this is the, function of this object or something that, does some sort of logic and not as like, oh, the general function of this, such as firewall management. So this is network function virtualization. I do think like software defined routers and stuff are really cool, but yeah, okay. NFV. Today is rough. We're only halfway through and it's half an hour. Okay, the dominant protocol that operates at OSI layer 3. IP is responsible for addressing packets that can be transmitted from the source. I guess it's saying IP, that it's TCP versus IP. Yeah. Okay, so IP is at layer 3, and then TCP for transport is level 4. A modernization of IP4 that includes a much larger IPv6 addresses 120. Yeah. Actually, this year has been the year I've seen more IP6 than I've seen in a long, long time. Mostly where just like at this point, every single mobile provider, all the cable hosts, they're all going to IPv6 internally. And then, just having a gateway for 6-to-4 translation at the edge of their network. ITs for virtualization. Okay. Did that even give us an answer? Oh. Their site's messing up now. Yeah, IPv6. Okay. Next. An interior gateway routing protocol developed for IP networks based on the shortest path first or link state algorithm. It's probably not BGP. It's OSPF. Hey, another 4-letter one for Mike Raymond. This sounds like a Marvel acronym, like the Office of Security, Protection, Freedom. Open shortest path first. Interior gateway. Based on the shortest. Okay. Representation of data at layer 3 of the OSI model. Okay, so we had layer 1 was bit, layer 2 was frame, layer 3 was, anybody remember? All right, layer 3, the dative representation. So we had frame, is it datagram? 3 is packet, network packet. Packet. Yeah, it's the network layer. But they wanted the dative representation of it, which was a packet. There you go. Am I switching too fast for people to answer? We weren't sure about the lag in this between me speaking and it actually showing up in stream. Okay, next. A technique called packet loss concealment, PLC, is used in VoIP, which is voice over IP, communications to mask the effect of dropped packets. I don't know how the answer to that is packet loss. So packet loss is definitely that. But wow. Interesting. I saw a crazy demo of how deepfakes are done with the AI networks. So for super low bandwidth video conferencing, they basically take your face and then have a model of it on each end. And so then when you speak, instead of the actual images and compression for the video going through, it just transmits the data to then reconstruct a model of your face on the other side. And they're doing the same thing with voice, almost like it was a text to speech of your own voice, and what was transmitted was just ASCII text. It was really interesting. Jitter. Oh, the question? Yeah, it was just badly phrased. Jitter would actually make more sense than this, but yeah. Provides a standard method for transporting multi-protocol datagrams over point-to-point links. A standard method for transporting multi-protocol datagrams over point-to-point links. So this is transport layer, segment datagram. I think what they're looking for is PPP. Yeah. Which isn't really used much anymore. The last time I remember PPP is super, using a 28K modem. You're like, oh yeah, we're using PPP versus SLIP. But oh my gosh, I can't imagine using that today. Okay, an extension to NAT to translate all addresses to one routable IP address and translate the source port number in the packet to a unique value. Hoping for an answer here. Someone wants to chime in. So NAT to translate on. So is it a gateway? Translate the source, or a proxy, or a router? Extension to NAT. Dynamic NAT? Something? Yeah. Ancient and outdated is right. Or like so theoretical, like I have no idea what this is. It sounds like IP? Sure, let's see if it's IP. No, it's port address translation. Extension to NAT. PAT versus NAT. Port address translation. Well, the first difference is NAT stands for network address translation and PAT stands for port address translation, which I guess makes, in the context of this, I think it's really just saying that it's handling the ports as well as just the address from internal to external. Yeah, it's NAT for a port. All addresses to one, like the source port number in the packet to a unique value. So if internally on my network I had, I guess what I don't understand is it because it's not just port forwarding, because port forwarding would be, straightforward, that it's, externally it's 1782 or whatever the port is. And so when that port gets hit internally, that gets translated to port 80. And then you have like someone externally looking at a web server that you put up, like you just use Python to launch a web server or something. Okay, so that's just port forwarding. That's not this, which I think is actually that you have multiple hosts internally, each with their own address. And then on top of that, it keeps them separated by port number. At least that's my understanding of this, but sure, I'm not the most clever one here today. If someone else wants to chime in with a better answer. Like a VLAN, but it's not, if that makes sense. I guess. I think a VLANs is internal networking segmentation. Exceeds maximum packet size and causes receiving. So I think this is a buffer overflow. Ping of death. Okay. This is weird. So just based on this words, which I'm probably going to start reading because I clicked on this. But exceeds maximum packet size. This is what we're talking about earlier with ICMP, where, it's an asymmetric, like you send like, this is way too big, but you send like 1 kilobyte and then you get back a megabyte of data. And that just overwhelms the system. Exceeding maximum packet size. I don't even think this is right. Exceeding maximum packet causes. All right. If they want to call that, I'm not going to fight with them. Network mapping technique to detect if a host replies to a ping and the attacker knows that a host exists at that address. What do you think this is? PAT is kind of what happens when you open a port on a NAT, whereas UPnP is an automatic protocol for opening ports. Okay. Network mapping technique to detect if host replies to a ping. So I don't think it's just ping. I think it's because I'm trying to get in. There is this whole thing with the CISSP where they talk about like the manager's mindset. Like, what is the generic way of describing this activity? And I think it's probably like port scanning or host scanning, something like that. Like 8-bit. Oni, you're saying like Nmap. That's too practical. Like, that's right. I mean, like, that's like what you would use for this, but they're looking for like the generic term. ARP, let's see. Ping scanning, port scanning. Yeah, port scanning is a real thing. But, ping scanning, like who says that in conversation? Like, I ping scanned all of it. Okay. Partial credit for everybody. Let's say okay. Ports 1024 to 49151. These ports typically accompany non-system applications associated with vendors and developers. I think they're looking for well-known ports here. This is my guess. Anyone else have a guess? Registered ports. I wonder where you register them with. Register TCP pool. Oh, with IANA. Now I feel like I would want to register a port for myself, but I'm sure there's probably rules in place to just prevent me frivolously registering ports for fun. Okay, ZAM has a good clarification here. Well-known ports apply to the ports before 1024. Maybe I know more ports than that. Ports that are owned by companies, so they're registered. I wonder how much that costs. I bet it's just a cost. Let's see. Port, what is it? Network port registration fee. I guess if you have to ask, it doesn't tell you how much it costs. Okay, moving on. Data representation at layer 4 of the OSI interconnection model. Okay. Rest where it says that apps use the function. I get that, you know, different apps use different ports. It's just interesting that, like, in the early days of the internet, when it's like, yeah, anyone can just register this thing, you know, and now I just wonder, there's a finite number of these. There must be some cost associated with them. I don't need to use it, but to claim it as your own, like, so. Hello, Ashafon. Ashafon? I hope I'm pronouncing your name correctly. Very nice to have you here as well. It just means an app can register to use the port on your network. Is that really what it means? Like, what do they register it with? I thought it just meant that it was registered, like you could look up in IANA and see like, oh, this port belongs to this company, so if you see traffic on it, most likely it's from XYZ network device. So, all right, everyone saying segment. It's nice to have some actual answers instead of people just arguing with me. Thank you so much. That's so nice. All right. Is designed to manage multimedia connections. This is going to be one of those, like, it's an old protocol. No one uses this anymore. Like RTMP, real-time multimedia protocol, something like that. Anyone else have a guess? My guess is RTMP. Session initiation protocol. Not what I was thinking. Let's look that up. Session initiation protocol. Terminate real-time sessions. Okay. Include voice, video. So I think the distinguishing thing here is that this has timing based into it. SIP. Manages voice and video. Very good. Format of messages, text-based protocol, conjunction with other protocols. Oh, look, and here's RTMP. Man, we're going to have to go quicker here. All right, speed round. ICMP echo request sent to the network broadcaster with a spoof victim causing all nodes to respond to the victim and reply with an echo reply. It's not ping of death. Ghost ping. Smurf. It's used a lot in VoIP. Ping Smurf. This stuff is real old. Okay. Separates network systems into 3 components. Data, how the data is sent, what purpose the data serves, focus on data control and application management functions or planes. Network control, network management, software-defined networks. Interesting. 3 components. Okay. Extension of the SDN practices to connect to entities spread across the internet to support WAN architectures. SDN, software-defined network practices. Software-defined wide area network. Kind of obvious, but okay. Operate at layer 2. A switch establishes a collision domain per port. Operations at layer 2. Ethernet and frames. A switch. Switches. Okay, so that operates at layer 2. Oh, it's telling us what it is. Okay, provides connection-oriented data management and reliable data transfer. TCP? Yeah, there you go. Transmission control. Just chime in with answers if you have them. We have to move quick because, yeah, it answers itself, which is frustrating because you think it wouldn't, so you don't think of the obvious answer. Exploits the reassembly of fragmented IP packets. Fragmented house field. Teardrop attack. Reassembling. Teardrop attack. Okay. Layering model structured into 4 layers. Network interface layer, internet layer, layering model. The TCP IP model. Okay. The user datagram protocol provides connectionless datagram. The answer is just going to be UDP. Let's look at datagrams. So UDP is a datagrams. So the TCP IP stack, UDP. Yeah, UDP. Okay, allow network administrators to use switches to create software-based LAN segments. Can be defined based on factors other than physical. Like software defined, virtual, VLANs. Switches to create software-based LAN segments. I like OSI better. Why? I feel like OSI is more theoretical than the TCP IP model. So here's a question. So the answer to this is VLAN. Okay. So a VLAN is that's essentially making like, I guess not a hub, just a virtual network segment. Yeah. VLAN makes like a virtual network segment. I love the VLANs. Okay. Technology allows you to make voice calls using a broadband internet connection instead of VoIP. It's VoIP. Lame. Okay. Ports 0 to 1 are related to the common protocols. So these are well-known ports. Okay. A whitelist is a list of email addresses and or internet addresses that someone knows as good senders. A blacklist is one of them. Well, kind of defines itself here. Blacklist. Okay. Yeah. A really common one is you can look up almost all of these, like all the ones for spam are just freely available. So you can look up all the lists for that. So, okay. Primarily associated with computer networking, Wi-Fi uses the IEEE 802.11 specification to create a wireless. Yep, that's what it is. How's that even a question? Okay, one well example of wireless broadband is WiMAX. 30 megabits per second. Okay, well, not entirely sure about those last couple. They just seemed like it was defining what it was. Okay, let's go through. Sorry, hit the wrong one there. All right, let's go through the chat and see who should get a mug today. We're just being kind of loose with this. Let's see. 8-Bit had a lot of good answers today. Real Zam, pretty good. A lot of stuff. Lag is pretty high. Sorry about the lag today. Really appreciate everyone chiming in. I hope you find this helpful. We are still trying to figure out the format for this. So if you have suggestions, leave them as comments or, put them in chat. Okay. Real Zam. I'm thinking today's winner is the Real Zam. Real Zam, thank you so much for all your help today, for explaining things. Appreciated. And we'd like to send you one of these mugs. If you want to, you can email me at m, as in Mike, Buckby @Varonis.com, and I will get that shipped out to you. All right. I think that's it today. Want to thank everyone for joining the stream. We'll be back next Monday at the same time. And I hope everyone continues to study for their CISSP. Thanks a lot. Have a good day. Bye.
Yeah, and just keep your eye on that end screen, and then it'll turn black, and then you can stop the stream.